Let me just give a quick introduction about myself. I am Abhinav Chauhan. I am working as a solutions architect with Amazon Web Services, and it's been total of 16 years of experience for me in the industry. I've worked with organizations like IBM, Oracle, VMware, and now Amazon. And today I was asked to present, and this is the first time I'm presenting in a university to students, and it's a very in topic, I would say. As you correctly mentioned, if anybody talks about generative AI, the first thing everybody can talk or relate to is ChatGPT, right? Which is the model which is available from OpenAI. So I will try and demystify generative AI for you. How does it come into being, and what are the basics behind generative AI? How does the ChatGPT model works? What are the basics behind it? And then after this session, we will try to finish this session maybe in 1.5 to 2 hours with a break in between. And then we'll have a quiz. And on basis of that quiz, there will be some participants which will be chosen for a further use case and a deep dive session. So do pay attention because on basis of those results which would be there in the as per the quiz and the use cases and the presentations tomorrow, there are prizes for you. And then definitely you get the extra benefit and the what do we say? I'm not able to find the right word, but encouragement to be part or associated with an IDEATHON being driven by Amazon itself. So in the interest of time, I'll quickly start my slides. So you can stop me anytime if you have a question in between. I'll be happy to answer. In case I don't know the answer, I'm not the expert in everything, I will get back to you. So on that note, these are the key questions which we are trying to uncover here. What is artificial intelligence and machine learning? So as a part of your curriculum, is it part, when I did my engineering, it was not part of it. We used to, the best I could remember was automata and neural networks, to something in relation to artificial intelligence and maybe machine learning, but nothing on those lines. So are these subjects part of your curriculum? Yes, sir. Have you already gone through it or going through it? The third year might have gone through it, the second year might be going through it. Is that the case? Yes. Okay. So I'll try and give a brief understanding from a technology point of view, the basics of them, and then what are the different type of machine learning. Then we talk about how does the generative AI come into the picture of everything, and how does it work. Then some of the practical use cases of generative AI. I know many of you have already used ChatGPT and tried to maybe shorten your project assignments and take help from ChatGPT. But that's just the start of it. Apart from generative AI, there are more than enough use cases which can be driven out of it. And then then what are the challenges actually associated with generative AI? Everything looks very good on the onset of it, but there is always this second side of the coin, which brings the risk to the generative AI field. So again, what this session is not. This session is to give you an understanding of how generative AI works. This is what are the practical use cases, and what are the responsible use considerations. This session is not a deep dive into what generative AI does on AWS, but we will try to give you an overview how generative AI offerings are there on AWS. I will even show you a demo of the console and the services which are available with AWS. Now, what is artificial intelligence? Anyone? Many of you said that you have already gone through it. Anyone? Yes?
Sir, artificial basically allow us to make machine capable of human intelligence.
Sorry, can you be a little louder?
Sir, it allows us to make machines capable of human thought.
Yeah, something on that lines, correct. Thank you for that. So basically, what is artificial intelligence? It is trying to simulate human intelligence via machine. So we, in this universe, humans are considered to be the most intelligent beings, right? So our brain is the most complex neural network. So similarly, we try to make machines as intelligent, we're still not able to make them as intelligent as humans, but we try to do the task, the repetitive task via artificial intelligence, and that process of building those algorithms to make that, to make the machines do our work is what is artificial intelligence. So, for example, this is a simple, very crude example, like if temperature is greater than 20 degrees, then turn on air conditioning. So basically you are training a data set, in this case an air conditioner. You are giving an instruction that if the temperature sensor from the IoT of that machine goes above 20 degrees Celsius, you need to do this action. So this is like building that artificial intelligence into the machine. And if it is less than 20 degrees Celsius, then turn on the heating part of it. Now, artificial intelligence is like a superset. In artificial intelligence, we talk about machine learning, deep learning, and then generative AI. So one by one, I'll be covering those aspects. So what is machine learning then? So in artificial intelligence also, we are training machines only. Then why does a separate term machine learning in terms comes to it? Because in artificial intelligence, we are dealing with a lot of different type of aspects, be it an IoT device or an algorithm or a server itself. But in machine learning, we are specifically working on algorithms, how to, we are actually programming them to do a specific function. And then we are expecting a result out of that function. So we are making models on top of that machine learning algorithms. We are making the training models, and then these are categorized into three types of learnings. First is supervised learning, then is unsupervised learning, then reinforcement learning. So now we'll quickly cover like what is the difference between, what is the basic difference between these type of learnings. So first is the supervised learning. So supervised learning is basically you tell the model like what is expected as an outcome. So you are actually training on the input data. So as you can see in this slide, you see that the first picture resembles a rose flower, then a tulip, then a sunflower. So we have categorically categorized them as per their type of flowers which they are and as per the picture, and that data has been fed into the model. Now when we put a sample image and ask what is it, then it will give an answer that it is 80% confident that it is a sunflower, because the image characteristics are like that. Then, and just one point I wanted to note, that be it generative AI, ML, nothing will ever be 100% accurate. We always talk about in percentage of accuracy, how much accuracy that model is able to give. Even now we talk about, like you talk about Google Translate, or you do maybe use it on your mobile day to day. Those things, like they will translate, but they will never, we have not still reached a position we can say they will be 100% accurate. Every day new things are coming, new models are coming. We were trying to increase the accuracy of same. Now similarly, if you talk about, this was supervised learning, when we have told the model this is the category, this is the specific flower, and this is how it is being trained. When we talk about unsupervised learning, and basically we data set, we give multiple images and we let the model train itself and define those boundaries. Now in out of these are flowers also, there are animal pictures also. Now if you give a sample image and ask what is it, it is going to categorize it in a group. It will not be specific, like in the last example it was able to tell that the model was 80% confident that it will be a sunflower. But in this, it is going to give you a category, a multiple answers, because it's an unsupervised learning. Then the last thing that comes is a reinforcement learning. So what is a reinforcement learning? It is completely different from supervised and unsupervised learning. So basically, it's an algorithm where you learn from your experience and experimentation, which is like trial and error. So in your houses, maybe you will have pets, like dog pets, right? Some of you will be having. So how do you train them? You tell them how to sit, where to sit, walk with them. You ask them to sit, they will sit. You ask them to stand, they will stand, right? And how do you decide, how do you enable them to follow them? You give them rewards for that positive actions. So similarly here, in this example, that there is a training, there is a robotic arm which is supposed to pick that package and put it in the right column. So how do you ensure that it does that? It will be doing multiple activities, but when it puts the package in the right column, it is given a positive reward, which is maybe a score in this particular example. And on basis of that, it is getting trained. So basically, it is basis of trial and error, and so multiple iterations are done, and then rewards are given. Once that rewards are given, then the model learns that I am doing the correct thing. So that is the third type of learning in machine learning, which is called reinforcement learning. So we covered supervised learning, which was for a very specific thing. We are telling the model that this is a picture of rose. Next time you give a picture of rose, it will tell with certain accuracy that it is a picture of rose. Then the second type was unsupervised learning, in which we talked about, we give a multiple set and the answer is not specific, but you get a different set of answers, like a set of data set is returned as an answer from the model. And the third is last is the reinforcement learning, which is like trial and error experimentation based learning, where you reward your training model on basis of the activities it is done, and on basis of that, after multiple iterations, the model is trained. Any doubts in this, like the basis part of it, what is machine learning and what are the different kind of machine learnings? But I don't expect you to understand each and everything, because it can be a little difficult, but I hope you get something out of the session and something out of the things which I'm trying to say. Do stop me in between and ask any doubts here. So next thing which we talked about artificial learning. We talked about then the subset of artificial learning, which was machine learning. Then the next part is deep learning. So what is deep learning? So basically deep learning is again a subset of machine learning only, and it could be how we are giving a lot of data to basically a model to train it on a specific outcome. If you see that we have a data set, the developer is working on that data set, and it selects and it will select that relevant feature. So we are actually training, doing a deep learning on that particular data set only to create it very specific to that particular domain. So for example, you train a model to recognize only the type of crops. So you are feeding maybe 10,000 or 20,000 images to a particular model to understand that this is wheat crop only and it's in different stages. So next time you feed a wheat crop to that, it will recognize that this is wheat at different stages. But if you feed a maize crop or a cornstarch crop, it will not recognize, it will give that this is not the wheat crop. So basically, deep learning is domain specific and putting that data set into the developer's hand and then extracting those relevant features out of it, out of that data set. So basically you do hours of study. Basically you are training the model multiple times, multiple iterations are being done. So this is just from an example point of view, like you can have number of bedrooms, locations and square footage. So for example, in a building you will, or in a house, how many bedrooms are there, what is the location of that house, then and what is the area of that house. We are training that data and giving that data set to that model to get a deep trained on. So once we do that training, then next time when you feed the data or you feed a sample image to that particular system, then the deep learning is able to automatically extract those relevant features and able to give you that complex relationship that this was a building image and this has multiple rooms, which has multiple square footage, what was the area of that room, how many rooms were there, which kind of a room was there. So basically deep learning is able to drive that complex relationship between that, for that particular data set. So basically when you talk about deep learning or deep learning algorithms, it is data requirement, your particular data set. It takes a lot of time to train. You need a lot of heavy servers to train it, and there's a good amount of cost also to it. So just to summarize, we have talked about artificial intelligence, which is the superset of everything. Then we go to machine learning. There are three types of machine learning: supervised, unsupervised, and reinforcement. Then there is a subset of machine learning which we go deep dive into a particular data set to enable the algorithm to have that, to understand the complex relationship between that data set and give you the answers. And then this is what we have covered up till now. Next is we talk about discriminative AI. So discriminative AI is nothing but we generally, the traditional AI and ML in the business, when we talk about the traditional AI which has been done before, you can say the chat GPTs or the generative AIs of the world, how we were able to maybe do a predictive analysis or maybe able to predict data, like how after, like we talk about, we are able to predict monsoons, we are able to predict earthquakes, we are able to, these systems are able to predict like what is the weather is going to be in next 30 days. So this is what this is like. They have a large amount of data, years and years of data, and they are putting it on a machine, training that machine, and that machine is predicting that what is going to be the weather tomorrow. So that is artificial intelligence for you. That is the traditional way of doing things. So basically it predicts a value or it provides you a classification, and we have seen in the example based on the decision boundaries which we have learned. So just an example of this is, let's just quickly, like as you were talking about that, for if we have this decision tree and it's just fed to the training algorithm, so it talks about if price is less than 3,000, then yes, it will be a bedroom which will be greater than 3, whether it will be sold, yes or no. So if we give an input, if we suppose ask it, will a house sell that is priced at $250,000 with 2 bedroom? What should be the answer as per? What do you think the answer would be? Sold or not sold?
Not sold.
That's absolutely right. It follows the decision tree and it will not be sold. So that's the traditional way how we used to do AI up till now. But since 2017, since the GPT was launched, things very fastly changed. Now we'll talk about generative AI and how it is different from the traditional AI. So we've seen this. This is what I was talking about. Like this is artificial intelligence is the superset. Then we go to machine learning. Then there is a subset which is deep learning. And in the end we have generative AI. So generative AI is nothing but a subset of deep learning. And it is based on something called foundational models. So again, we'll talk a little bit more on what is foundational models in the coming slides. But all your chat GPT is a foundational model basically. It's a foundational model on which that chat bot is based, where you can do a chat like you're talking to a human. You ask a question and in terms you get a response. Like many of you would have already tried it. Apart from the chat bot, there are multiple use cases also which we'll be discussing in the session which you're doing. Now, this is how it used to be like, I was talking about traditional AI ML models. Yeah, am I audible? So the food is okay, but the staff is rude. If you put it to a traditional classification, it just tells the sentiment is negative, right? But if you talk about generative AI, how it is different, how you ask to classify the review as positive, negative, and neutral. The food is okay, but the staff is rude. So the sentiment is again negative because the food was not. The food was okay, but the staff was not. Staff was rude. But then you ask based on the review, what can the business do to improve? So the LLM is going to give you suggestions. It is generating that data which was not there in the prompt. Basically, the input which you give to a model is called prompt, and then it is suggesting you or generating data for you, the suggestions for you. So that is where the difference comes in the generative AI space. So did you get the basic idea, the difference between a traditional AI and a generative AI? So generative AI is basically we are generating something which does not exist. When I say which does not exist, basically the model is giving an answer for you and helping you with the suggestions. It can be a text-based model, it can be a video-based, it can be a audio-based model also. So next is, again, I'm just summarizing like how traditional ML is different than generative AI. So generally in traditional ML you will be able to handle one type of data, whereas in generative AI you can handle multiple type of domains and data. And models must be carefully trained. Like I was talking about deep learning, in which we are specifically training the model, how that model is going to get trained. In the second part, the models are actually generating the content for you. We are not worried about the specifics of how the training is being done, but we are giving that model lots and lots of data. You must have heard about, we are giving trillions of tokens to the input models to get trained on. So that is the basic difference. Basically, generative AI is something which is able to generate content for you, which was never available in the data set. And it is able to correlate the sentences or the input which you are asking. I'll also show you a demo when the time comes, how it works on the AWS side of the things. Now the basis of generative AI is foundational models and large language models. We'll start with foundational models. So foundational models is nothing but is a large data set trained on various data sources. So for example, the chat GPT, then we'll come to the chat GPTs and the other models which are available. So basically foundational models are trained on massive amount of general domain data, allowing these models to be implemented or customized for different use cases. And those use cases can be text generation, data summarization, information extraction, chatbot interaction like you do it in chat GPT, and question answer responses. I know some of you must have definitely tried to solve your assignments using chat GPTs, right? So you ask a question to the chat GPT and expect an answer, but then that's the I'll talk about it, how like institutes are also working on technology which checks that whether the input or the answers have been given by chat GPT or it's been given by the candidate itself. So it should be used as a tool to enhance your productivity, but not as a replacement for your, I would say, understanding. So you should use it as to complement your understanding and learnings, not as a replacement of your work. So just continuing, so this is how it works. So basically in a traditional ML model, you give most of the label data. When I talk about label data, you will remember the example of supervised learning, where we were labeling the pictures of rose, tulip and sunflower. So that's an example of label data that is fetched or given to the machine learning model, and then that different kind of tasks are generated of the model. One can be a text generation, another can be summarization, information extraction, Q&A, chatbot. This is how the traditional ML model works. But when we talk about foundational models, which is the basis of generative AI, we don't label any data. So those models, which like the chat GPTs or the other models we talk about, those are not labeled. Those are like those have been trained on the data which is available on the internet. And internet, all that data may not be labeled, right? So it is like unlabeled data is fetched to the foundational model, and the foundation model is able to build that complex relationships and perform different kind of tasks as per the requirement of the application. So these are some of the use cases of the generative AI which is happening right now. So the most famous being, again, a lot of references to the chat GPT, because that's the most common available. So after this session, after the quiz, we'll talk about another platform which is available, which is powered by Amazon, which is also free and available for public access. which can help you build your prototypes on generative AI absolutely free of cost. So yeah. Next, again, just more of a repetitive slide actually talks about some of the use cases which foundational models are used on. Again, maybe the text generation or the summarization, like you reader, you have a lot of content to read, and you can actually summarize and read and give you a summary of the context for a complex architecture. That is one of the use cases which I think might be useful to you. And the third might be the code generation. So are you guys on like working on any like code? Any of you are working on any code? Or has anybody used ChatGPT for generating a code? So there is, I see few hands. So that is one of the use cases which developers use, which is actually not as a replacement, but to again I would say complement their work to increase the speed of their productivity. Now, what is a large language model? So as we were seeing that generative AI is a subset of deep learning. Similarly, large language models are a subset of foundational model. A large language model, as it suggests, is particularly trained with a particular language. So basically, it is trained on trillions of words. It's a language model. So for example, ChatGPT is like trained on English words, trillion of English words, so that it is able to give you that output and understand those correlation and complex prompts and inputs which you are asking, and then is able to give you the answers. And it is the model is able to adapt to different use cases, be it text generation, text summarization, or sentiment analysis. Any questions? I hope things like I've tried to keep it very level 100 so that you are able to understand the basics. We are not going into the much of the deep dive stuff on the background, how actually things are working into the neural networks or the transformers. We will talk about the transformers in the coming slide. But I hope it is making sense. A yes or a no will help. Okay, thank you. So again, just an example, like you are training a data set, and for example text about football, and then during the training, the network is gaining that understanding of that language and the context. And the important part from a LLM or like a generative AI is understands the context of the sentence which you are saying. So I'll show you here an example. So like we have fetched or we have trained our data on football data. So now my football club is from Australia. The football, so the large language model will be able to predict the next word. It will be able to fill the sentence for you. You might see it as a very simple thing, but it's a very complex algorithm working, because for this football, it can be a team, it can be a club, it can be football champions or a game. There are millions of combinations possible. But the model is the neural network, the LLMs are able to predict the next word in the context of the input which you have given. So that's what makes them very unique and different from the normal approach of traditional AI ML. So just to the idea is to, for the LLMs, is to predict the next word. You can always ask like today weather was like this, and what is the weather going to be next. If that data is available with the LLM, it will going to give you a response. So it may also happen that sometimes irrelevant data is also given as an output. So don't worry, it's an iterative process. You have to improve the input to get a better output. Right now there is no mechanism or a very good practice which gives you a best output, but these are like hit and trial methods right now. We'll talk about how you can better the accuracy of the prompt so that you get better response out of the model. So just to give a little background on the large language model lines, in 2017 a transformer architecture was born, and I'll talk about the basis of transformers. Then 2018 the first GPT-1 came. Anybody knows what's the full form of GPT? Sorry? close to it, not exactly. It's chat generative pattern transformer. So where does the transformer comes from? Transformers are the basic neural network models on basis of which these particular models are being made. Then GPT-2 came, GPT-3, which is like the most common one when it was widely adapted as Chat GPT. In 2022, all these other models from other companies came into the picture. And in 2023, we had GPT-4. So if you go to Chat GPT and you want to use it, this is the Chat GPT-4 Pro model which is we are using at the back end. And then we have different models like Amazon Titan, Claude, Llama 2, Mistral. Llama 2 is the Meta's model, which is like made by Meta organization. So I was talking about predicting the next word. Actually, we do it day in and day out. So if you see this example, this is like an example or a video of a phone where it is automatically, it's auto-correcting and auto-filling the next word. It is predicting that. So we actually have been using it for quite some time in our mobiles. But that has been trained on very small set of data. You can't ask a question to it. It is just like completing the sentence, right? It is predicting the next word and completing the sentence. So this is an example of like again a large language model only. Now, how do you interact with a LLM? So you give a prompt, which is the input you give to the model, like you in Chat GPT or any generative AI model. The input is called prompt, and this example is talking about give me a list of 5 biggest cities in the world, and this is the desired format because we have defined the format: city name, population, and country. This is fetched to the LLM, which does the inference, and then this is how the answer you get. Because you have specified the format, you are able to get these are the 5 cities of the world, and as per the population, as per their city as well as the country, and these figures may vary as per the data. It will tell you about the source also where it is taking the input. Now something on how do you work with these LLMs, how do you make applications with these LLMs? Because ChatGPT is like an application which is publicly available and you're able to. It is a chatbot. It is kind of an implementation or an application use case for you, for end users like you and me. So the basis is a transformer architecture. We will touch a little bit on this. I'll not go deep dive. But then is the configuration part. We'll talk about this in a deep dive session after the quiz. And then what kind of an LLM should be chosen as per your requirement, whether it's for a text generation or a video generation or it's a multimodal LLM, like it can do text and video both. So for example, a multimodal LLM is like a Claude, Anthropic, I don't know whether you have heard. There's a company called Anthropic Labs, which are developing one of the fastest LLMs in the current state of things. It's called Claude. Claude Sonnet, Claude Haiku, Claude Opus. You might have heard about these names. So then is the application integration. So then how do you make them use cases business ready, right? A Chat GPT is a business use case. You might be using a free version, but there is a paid version also. The company is making money out of it by selling that subscription to the users. Now we'll talk about a very brief on the transformers architecture. Has anyone seen this before? Out of personal interest, or I don't know whether it's part of the curriculum or not, but any raise of hands who have seen this diagram before? Okay, so just to give you an idea, so what is happening? This is how we start. This is the flow of the backend of the LLM. This is the input. This is the prompt which you have given, right? Which are the 5 biggest cities in the world? This is that input. That is converted into an embedding. Embedding is nothing but converting that prompt into vector, because at the end of the day, it is being processed on a server or a computer, and computer only understands zeros or ones. So this is basically that embedding is converting that sentence or the input which you have given into zeros or ones, and this is called vectors converting into vectors, and that process is called embeddings. Then embeddings is fed into an encoder, which is the part of the transformer architecture, which actually understand the context. Like for example, if you have to translate, my name is Abhinav. If I have to translate into Hindi, मेरा नाम अभिनव है. It is not simply translating my name is Abhinav, मेरा नाम अभिनव है. So it has to understand the context of this of that particular language it is going to get translation to, so that understanding of the context, different context is happening on this transformer, encoder and decoder. And the basic difference between this architecture is we are able to do parallel operations in this architecture, which is able to give you that accuracy and speed. So for example, that model is trained on trillions of parameters, but still when you ask a question to that model, you are able to get an answer within a few seconds or maximum a minute, depending upon the complexity of the data you are asking. But that in the back end, that prompt is getting divided into embeddings. It is running through that whole architecture and it is giving you an output. That is taking a lot of compute cycles and a lot of compute power is required to run those chat GPTs and all those models which gives you an answer. So I'll not go deep dive into it because it will become very difficult for you also to understand. But if anybody has a interest in this, can contact me after the session. We can have a discussion on this. Now we're supposed to take a short break, but in the interest of the time, I will skip that break. It was just a quick 2 minutes break only. And we'll continue with the session because we started a little late, and we will take a break afterwards. I hope that is okay. Yeah? Okay. Just give me a minute. Now, as I was talking about structure of a prompt, now I'll talk about the prompt itself. Like what the input is the prompt, how do you give that prompt so that you get a better answer? Or what are the different type of techniques which are available in prompting? So basically you give an instruction in the prompt, you give the context. Like instruction is summarize the following restaurants review on a bulleted list. But you're also giving the context, like which restaurant we are talking about. Then you are giving an input that this was the review which was there in the prompt, and then you are expecting that output should come like this. So if you tell this and if you give this prompt, then the answer of the LLM will be specific in this format only. So you are actually structuring your prompt in a correct manner to get a better answer. So there are majorly three types or four types of prompts which are available. First is called a zero-shot inference. What does that mean? Classify this tweet. This was a great show. This is like a zero shot. You're not saying, you're just asking a single shot answer, and it will classify that this was a great show. That answer is positive, right? Because it's a positive statement. That is how it is going to qualify that. Then we move to one-shot inference that classify this with I love this city, answer is positive. Then it will ask classify this tweet, this was a bad show. So then it was a bad show, you have told, give one example that how you are classifying that this was a positive. Now you are asking for the next tweet. The next tweet is a negative review because they are classifying it as bad. Then few shot inference in which you are giving multiple examples. So on basis you are actually giving the context to the model that what kind of an answer you are looking for, and what kind of a context is the thought process is there for you to get an answer to. So that is how when we show in the demo, I'll show you the different mechanisms also, that if we give this to the if we ask this question to the model, how the different answers will come. Any questions on this? No questions? So I understand this topic may not be part of your curriculum, but trust me, these days when we go in the field, I actually am working with multiple states as I'm part of the state government, and every other customer or a state department only talks about how we can use generative AI in our use cases. Okay, so somebody is looking to use generative AI to make an automated CM helpline, right? That the call comes and there is an automated response given on the basis of the problem statement which has been given by the citizen. That's the one use case. The other use case is one company or one department wants to, have you heard about RFPs or tenders? Like if in a government you want to procure something, they float a tender or a requirement. They want to automate that process by using generative AI. They want that there should be a model trained on their data set, on their tenders, that next time they want to float a new tender, they can just give a prompt. They can just give a prompt with, that will be like, they can give a prompt and then that prompt can end into generating a tender for you. I'm just giving you that context that this is very important from your future point of view, because this thing is going to stay. It will be very useful if you understand the basics in the college itself, right? Because when I did my engineering back in, I was 2008 pass out, so nothing was there. These things, even the AI or the ML part of the things, nothing was there. It was used to be like I was talking about the normal CS subjects. The closest thing I can remember was neural networks, which I don't remember a thing about now. So, but these days, the curriculums have been adopted to what is going in the industry actually, and which helps you in your job also. So yeah, moving on, again, just summarizing, there are actually 4 types of zero shot, one shot and few shot prompting. Zero shot, we don't give any example. One shot, we give one example of how we want the output to be. In few shots, we are giving multiple, we are actually giving a structure to our prompt and multiple answers and questions to it, so that the next question is asked, it is given in that particular format. Chain of thought is a complex, that is why I'm not going into the detail, but this is like kind of like you are putting multiple thoughts to the model, how you are doing reasoning behind it. So moving on, now let's talk about a little bit on the, these were the basics. There was nothing in relation to AWS or Amazon, how Amazon does artificial intelligence and all. Now we'll talk a little about what are the offerings from Amazon and how you can use it, what are the use cases behind it, what are the different services which are available. So this is a quick video. Do we have audio? Anybody has any idea? Can I connect? That's okay. I'll try and start. Apologies for the audio. Up till now what we have spoken. So up till now in this quick video, it's a very small video only. What we have spoken about is that only that how generative AI is based on foundational models and large language models. And the video will give you an example like how generative AI is different from a normal AI/ML model. How we were talking about different of differences between a traditional AI/ML or a generative AI/ML. So meanwhile we wait for the audio to come. We can just, if you have any questions or any specific thing to ask, yes. Database management depends upon what you want to use from database management.
Manage database.
To manage database, yes, some of the tasks can be automated.
anyone can easily create art, generate code, or even write a haiku. And who doesn't? Haiku. Generative AI is transforming all types of industries. But what makes Gen AI so revolutionary, and how does it work? Like most artificial intelligence, generative AI is powered by machine learning models, and Gen AI models are commonly referred to as foundation models. Before foundation models came along, traditional forms of machine learning were primarily task-specific. For example, if you needed to translate a paella recipe from Spanish to English, the model would only do the translation work. With Gen AI, you can not only Thanks to Gen AI, you can easily create art, generate code, or even write a haiku. And who doesn't love a haiku? Generative AI is transforming all types of industries. But what makes Gen AI so revolutionary, and how does it work? Like most artificial intelligence, generative AI is powered by machine learning models, and Gen AI models are commonly referred to as foundation models. Before foundation models came along, traditional forms of machine learning were primarily task-specific. For example, if you needed to translate a paella recipe from Spanish to English, the model would only do the translation work. With Gen AI, you can not only translate the recipe, but you can go even further and create an entirely new recipe, like a vegan paella, if that's what you prompted the model to do. You can use Gen AI to create new content of all kinds, whether something simple like writing custom captions for images, or far more complex like developing more effective drug molecules. The breakthrough for foundation models came with a neural network architecture called Transformer. This technology entered the conversation in 2017 and is like the Swiss Army knife of AI. With Transformer architecture, there's no manual data preparation, and because of the massive amounts of pre-training, aka learning, the models can be used for a wide variety of generalized tasks. This adaptability and ease of use are really what makes generative AI unique. And as more people get access to Gen AI, this technology has the potential to transform our daily lives for the better, helping to solve some of the world's toughest challenges in education, healthcare, climate, and beyond.
So, yeah, the idea of showing you the video was that there are multiple use cases of Gen AI, and as one of the use cases was that it was giving an example of translating the buyer recipe from Spanish to English. But you can, on top of it, you can add your requirement that you need a vegan recipe. It will give you that recommendation also, how to make that a non-vegetarian recipe into a vegetarian recipe. So that's generative AI for you, understanding the context and giving you the answer on this. So this slide is generative AI stack from AWS. Amazon Web Services. At the bottom, where is the infrastructure? So, as I was talking about, to train a foundational model or a large language model, we need huge amount of resources. It is not like something like you are running a web application or your, for example, your college portal or a website runs on like 2 or 3 servers in high availability. But for this, we require multiple different like set of GPUs and CPUs to train these models. And we have multiple type of offerings, like starting from GPUs. Trainiums and Inferentia are the chips which are specifically developed for this purpose by Amazon for this. And then SageMaker, I'll show you the console, the SageMaker also, in which we are able to basically do a customized machine learning. You can bring your own models and work on this. And then the other part is the Amazon Bedrock. So basically OpenAI was the first one to launch their the models, which is the ChatGPT, which many of you have already used. But our Amazon's introduction to generative AI is Amazon Bedrock, where you can, it's more like a marketplace of different foundational models which are to be used for your business applications. Then, in the end, on top of this, we have built Amazon Q, which is GenAI based conversation chatbot depending upon the different use cases and different work. So one of them can be very relevant for developer. I will share a video link with you, which is a YouTube video which you can see afterwards, in which you are basically seeing how generative AI is helping you to help you with your developing the code or even transforming the code from one language to another, C to C++, to Java. That code transitions can also happen. So this is how a console or a Jumpstart SageMaker looks like. Then we have Amazon Bedrock. It talks about like how we are able to choose different foundational models from AI 121 Labs and Anthropic, Stability AI, Amazon's own foundational models, then Meta list. The list goes on, and then there is an option for you if somebody in an organization has built their own foundational models, but they want to host it. Is it better? Is it better? Yeah. Apologies for that. So what I was saying is Amazon Bedrock is basically Amazon's offering for generative AI stack. That's the main offering we have. We choose to have multiple partners. We are not like, if you compare it to someone like OpenAI or Microsoft, that we have one model like which is ChatGPT. But we are working with multiple partners. We have multiple foundational models like from AI 121 Labs, Anthropic, Stability AI, Diffusion AI, then Amazon's own lab. I'll show you the console and I'll run you through the different models and their use cases. And then if an organization or if, for example, your college builds their own foundational model, but they want to host it on Amazon Bedrock, that option is also available as a private customized model to be used as a PaaS service. So Amazon Bedrock, for your understanding, it's a PaaS service. When I say PaaS, basically you are not managing the underlying infrastructure. You are just consuming the service. You are not worried how it is running, what kind of a CPU or a GPU is required. You are just getting the interface to it. So yeah, this was the video. I'll share the link with you for this. Now, from a practical applications point of view, what I'll do is I'll quickly show you the demo first. Or do you want to see the demo in the last? Last? Okay, there are like 5 or 7 slides more, and then we can do the demo. So basically, what are the practical applications? I was talking about multiple use cases which are already there. The first one being the major one being content generation. So when we are able to generate content, for example, when some of you might be interested in writing your own blogs, so you can take help of generative AI to write your blogs for you. They can create social media posts for you as per your requirements. Then prototyping. There is, like I was talking about, have you heard about Party Rock? Anybody? Like ChatGPT, have you heard about Party Rock? So basically, I'll show you a demo of that also. Party Rock is it's like a website or a portal you go to where it is powered by Amazon Bedrock, and you can build your quick prototypes. Like you can build a resume screening app. You can build a personalized content or a health app. You can build a movie recommendation app. Depending upon the inputs you give, it will recommend movies to you. So it's open, it's publicly available, it's free to use. Anybody of you can just go to partyrock.aws and use it. So So next, then we come to data analytics part of it. We also sometimes say it generative BI, which is basically using the dashboards and generating. So these days, customers like my end customers, they want quick dashboards for their higher management. They want reports. For example, use case for college institutions can also be the student performance reports. So when an administrator or like HOD of a department just writes that I want the report or the graph for student A in this particular format in a natural language. He's not giving any command, he's just writing in plain English. Then it should be able to give you that graph. So that's the capability of generative AI. That's the possible use case of generative AI. Then is the content analysis, and then chatbots and virtual assistants we all are very well aware of. And in the last, there is no bound to the use cases. The creativity has no bounds, so you can be very creative in using those generative AI use cases. So this is like one of the hello? Yeah. So one of the examples or one of the customer statements when they used Amazon Code Whisperer. So Code Whisperer is nothing but Amazon Q for developer now. So they used it in their industry or their organization, and they were able to improve the productivity by 30% of their staff or the developers. Basically, and inclusive AI. So when I was talking about responsible, that you need to understand the scope of generative AI very well. So it should not happen that you should not expect that it will do everything for you. There are guardrails put into the system, even in ChatGPT or any of the AI model, that will not do each and everything for you. Then you need to understand the hallucination part of it also. When I say hallucination, that sometimes these large language models or these foundational models will hallucinate data, right? For example, you will ask a question, which is the biggest city in India, and it may not give the right answer, right? It may say it's Mumbai, but actually it may be Delhi, or I also don't know the correct answer. I'm just taking an example. So those are called hallucinations. So in a practical or a business use case, we try to reduce those hallucinations using different type of prompts and fine-tuning our model. Basically, there is a mechanism to fine-tune the foundational models by giving a particular data set. So those are actually used in business applications. That's why it was not covered today. This session was more on the basics of it, so that you understand the basis of generative AI. Then the next part is plagiarism and cheating. So again, because this is an important aspect, and we see everyday new use case of cheating and plagiarism coming because of generative AI. People writing their research papers using generative AI, right? And which should not be done. It should be used responsibly. You because feedback is always important. It helps us to improve our next sessions and what needs to be covered more. But any feedback from you right now, like how do you find this session working? But yeah, session is not over. Demo is still there. I'm still gonna hold you for some more time. Yeah. Just give me 1 minute to set it up, then we can start. Okay, so has any one of you seen this screen before? Yes? That's very good to know. So, is this like, have you seen this out of your own interest, or is it part of your curriculum to have a working knowledge of AWS console? Curriculum? Yes. That's very good to know. So basically, this is the AWS console, and then many of you are already aware of it. I'll quickly go to basically this screen gives you the recently visited services which you have used in the past. And right now, as I talked about Amazon Bedrock. So basically we go to the Bedrock, as I was telling you, it is how easy you can build your applications, and with using foundational models, we just simply first click on get started. So these are some of the foundation models which are available in Mumbai region. So basically the important point is whenever you log into your AWS console, you need to first check in which region you want to deploy your services. Whether it's going to be Mumbai region or it's going to be outside India, then it will be maybe Singapore, US, whichever region you choose. But particularly for me, as I work with public sector, we only work within the guardrails of India, which is like for Mumbai and Hyderabad. So the first thing when you go to a Bedrock console, what you need to do is you need to first have the access for different models, which you will be using for